This is Mr. Beck Does Your Homework. Question number 5. It says a particle whose mass is 2 kilograms moves in the xy plane with a constant speed of 6 meters per second in the positive x direction along y equals 6 meters. It sure would help to see a picture of this. So here is my xy plane. This mass here is moving along with a certain velocity, and it happens to be zipping along at a height of y equals 6 meters. So this point here is going to be 6 meters. Then it says find the magnitude of its angular momentum relative to the point xy, x0, y0, where x0 is 0.8 meters and y0 is 13 meters. So that point of x0, y0 is going to be at 0.8 and 13. It's going to be somewhere up here. So I want to find the angular momentum of this object around that point. To calculate the angular momentum of a particle at a point of time, if it's not moving around in a circle, we need to know the distance that it is away from that point. We need to know the angle between those two. And what we find out is that my angular momentum, L for that moving particle, is going to be the mass of the particle times that distance, which I will call r, times the velocity times the sine of theta. But I can see that r times the sine of theta is going to give me this distance here, this tangential distance, which just for kicks I'll call big R for now. Now it should be obvious that r times the sine of theta is going to be big R. So what we wind up with for the equation for the angular momentum of a point particle is that angular momentum is going to be the mass times the velocity times how far it will be at its closest point when it's tangent to a line drawn to the particle. So that is just how far it will be when it is here. So this is my distance that I'm interested in. So if I want to calculate the angular momentum, I've got the mass, it's given right here. I've got the velocity, it's given right here. But now I need the r, and the r is going to be the difference between this height and this height. For me, y is 13, and this is at y equals 6, so it'll be 13 minus 6 to give me the difference there. And that will give me my r, and that is the angular momentum of that particle.